Hello, welcome back to 8-6 radical expressions and rational exponents. So I've been hinting at this idea in the last couple videos, the first two videos in this section, and this really, you've got a lot of problems in this section where we're going to simplify. So we're going to really try to understand radicals and how to simplify with that. But this is where we give you the big mystery behind radicals. Why do some teachers not put the R in PERMDAS? And one of the arguments that I've heard is what I'm going to teach you. You don't need it. All you have to do is change the radical to an exponent with a fraction, which is what we're doing in this video. And my argument has always been that's true. So then leave out the subtract and the divide. But I'm not going to waste valuable recording time ranting about that. So what I said is what I just meant. In the previous, let me grab the paper, I kind of hinted at this a little bit. Okay, so like right here, if I look right here, I got 4 divided by 4, which equals 1. This is 2 to the first power. 6, look at just the x's, 6 divided by 3 equals 2. I ended up with x to the second power. And then down here I had 9 divided by 3, which equals 3. I ended up with x to the third power. So it turns out that another way of writing a radical is to convert it into a fraction, convert it into an exponent that is a fraction. Oh, sorry. So we got a couple of examples here, all right? I'm going to talk about them. If you see, I don't know why they do it this way, because we're going to, okay, yeah, I guess we're going to start with the fractions. In the next video, we're going to go back the other way. Okay, so we're cool. All right, if you see something to a fraction exponent, the numerator of that fraction becomes the exponent under the radical. So there's the hidden 1. I guess this was a bad one to think about. And then the denominator is the index. So I can do like 16 to the first power, the 4th root of that. So I take the 1 divided by 4 and I get the 1 over 4. So in general, if I have a number to a 1 over n power, that's just the nth root of that. So what you've been seeing all along with square roots, the square root of 25 was actually the whole time 25 to the 1/2 power. And this actually does kind of make sense, because the square root of 25 is asking this question: what number times itself equals 25? Since the square root of 25 is actually 5, the square root of 25 is not 5 times 5, that's 25, so it's going to be half of the product. Half of the product. So half of these factors is going to give me the half exponent, which is the square root of 25. So that's kind of slick. That kind of works out. What happens if it's not square root? So that, for example, we'll use this one right here. I know that the cube root of 8, that's going to be 8 to the 1/3 power. And since 2 times 2 times 2 equals 8, if I split these, don't draw lines, I'm just doing it to make an example. If I split these, this right here, just that 2 is 1/3 of the factors. So that's kind of cool. The number that's in the numerator of the fraction of the exponent ends up being the overall power. And this is good because it shows two things, right? So for example, if I had the 7th root of x to the 3rd power, and I'm using x just because I don't want to worry about simplifying or anything, I can write it this way, or I can write it like this. So that exponent can go directly on the number under the radical, or it can be over the whole thing. These are the same. And the reason why they are the same is because exponents and radicals are the same thing. They're just two different ways of writing the same thing. All right, so you're learning this for the first time. You're learning the language of algebra, how we write things. That is, again, like I've said before, that's not something that people are born with. So this is really why it's important that you get guidance and that you ask. I'll do my best to like make it make sense. Let's do a couple of examples. And I copied all these from the book. Write the expression negative 125 to the 2/3 power in radical form. One thing is really important, and I'm glad they did this. Notice parentheses, but no parentheses here. Just off to the side, negative 3 to the 2nd power equals negative 9, for example. But if I put parentheses around it, negative 3 to the 2nd power with parentheses equals positive 9. So what's the difference? This with the parentheses is saying negative 3 times negative 3, and a negative times negative is a positive. Without the parentheses, it's saying what's the opposite of 3 to the 2nd power? 3 to the 2nd power is 9, and the opposite of that is negative 9. So again, this is not something that comes naturally. This is just language. It's code. So just remember what the code means. When you see it without parentheses, that's the opposite of, you do the exponent first, the opposite of whatever the power is. And when you see it with parentheses, it's saying, no. It's the number negative 3 that I want you to square, okay, in that example. So in this case, it's the number negative 125 that I need to raise to the 2/3 power. What does that mean? So let's write it in radical form. So I'm going to first write my radical, and under the radical I'm going to write negative 125. I'm going to keep it in parentheses. Now, the 2 is the exponent on the negative 125. Okay? Just like over here, all right? Because remember, the number is negative 125. If I don't put the parentheses here, it's going to mean this instead. Okay, so be careful with that. The 3 in the denominator is going to be the index of the radical. All right, now, a moment ago, I said that's the same as that. Why is that important? Because if I'm going to simplify that, I can do two things. I can take 125, negative 125, and square it. I don't want to do that by hand. I do have a calculator. I can do 125, oops. I didn't want to do that. Second quit. Second quit. There you go. Clear. I can do negative 125 and raise that to the 2nd power. 15,625. But I also know that I can do this. Cube root of negative 125. Now, you're saying, wait a second, you got to put parentheses around that. Hold on. The whole thing is in parentheses, and then I'm going to square it. So you do what you think is best. You're going to end up with the same value when you simplify it. Either way, this one, if you square it first, you're going to get a big number, 15,625. And then you have to say, well, what number times itself equals 15,625? That's possible. It's very possible. There's nothing wrong with doing that, but most people kind of struggle with that. I think I would. But going this way, I'm going to cover up. It didn't go. It didn't go anywhere. It's still there. I'm just going to cover it up so we don't look at it. This is saying what number times itself equals negative 125. I think I already talked about this in one of the previous videos. So this is going to be negative 5 to the 2nd power, which is then going to equal positive 25. So for me, I think it's easier to go smaller than back up and go bigger than to go way big and then try to go smaller. But your mileage may vary. You do what you need to do. Both ways work. Let's talk about 64 to the 1/3 power. Since the numerator of this rational exponent is 1, I'm going to have 64 to the 1st power. Normally we don't write that. That's one of those things that we have hidden. However, I'm going to do it for demonstration purposes. I'm okay if you write it, because I'm always okay with you showing hidden stuff. But I want you to see where that goes. Where does the 3 that's in the denominator go? That is the index of the radical. Okay? So what this means is 64 to the first power, that's just 64. Like I said, that'd be the same as if you didn't show the exponent. And what number times itself again equals 64? Well, this is just going to be positive 4. 4 times 4 times 4 equals 64. So this is just another way of saying the number 4. If you have a younger sibling who's having a 4th birthday and you're making the cake, just write happy 64 to the 1/3 power th birthday. The rational exponent for this one is 5 over 2. So the numerator 5, that's going to become my exponent on my 4. And then when I take my root, the denominator, I know the difference, okay? The denominator here, 2, it becomes the index. And again, we usually don't write the index of 2. I'm doing it because we're showing everything. Now, just like this one, I could go ahead and do 4 to the 5th power, okay? I mean, you could do this. I'll do it for you. 4 to the 5th power. And then I'm going to take the square root of that. I'm going to end up with 32. So it's possible. However, if I don't have a calculator and I don't really want to do 4 times 4 times 4 times 4 times 4, I could also write this as the square root of 4, and I'll leave the index there. That's still the square root. Then I'm going to take that and raise it to the 5th power. These are the same. They mean the same thing. So by taking the square root of 4, I get a smaller number, which is 2. And of course, 2 to the 5th power, we should know, is 32, which is what I said it would be. All right, last one in this section, then we're going to look at all of them just real quick together. 625 to the 3/4 power. This is going to be 625 to the 3rd power, and the denominator in the exponent 4 gives me the index of the root. This is the 4th root of 625 to the 3rd power. So just like last time, I can do 625 times 625 times 625. 625 to the 3rd power. Yeah, that it's not impossible, but you might have a while to get that if you're doing it by hand. But here's a better way of doing it. This is the same as the 4th root of 625, which I know is 5, then raise that to the 3rd power. So this becomes 5 to the 3rd power, which just becomes 125. So before I stop recording on this one, I just want to point out, I want you to look at all of these just to get that first step. The simplifying part, that's an additional degree of difficulty. But the important thing to get out here is the first step. So when I had this number to the 2/3 power, the 2 is the exponent, the 3 is the index of the radical. When I had 64 to the 1/3 power, the 1 is the exponent, and the 3 becomes the index of the radical. Same thing. 5 is the exponent, 2 is the index, 3 is the exponent, 4 is the index. And then after that, you can simplify. In the next video, we're going to reverse that.